Amanda, please.
All right, we are reconvening here in the room. And we will begin the roundtable discussion. Thank you again to all of the presenting subcontractors. And the first thing I think we can do is to address any questions that folks have about any of the presentations that you have seen thus far. And then we can just open up a discussion. Anyone who wants to, you can unmute yourselves to talk. You can submit questions through the chat and I can read them out. And anyone who wants to turn on your cameras as well so we can see who we're talking to, that would be wonderful.
Anybody have any questions for the presenters? They want clarifications or anything? So we must have had.
I'll jump in. This is towards Fernando and your group, the studies that you presented. You alluded to the DHA requirement on broodstock. Did you actually determine a DHA requirement or was it just based on publication review?
No, it's based the qualitative requirement. That's why I specifically say qualitative. We didn't do a quantitative study. It was based off of we did a ratio from the diet DHA amount to the egg DHA amount, and then we compared that.
Are there plans to kind of verify and maybe we actually do a quantitative omega-3 requirement?
That's a question for Paul.
I'll write that down.
All right. And then follow on to that, where you were looking at fish meal replacers. And this kind of ties into Alan's presentation as well. The usually one of the main objectives, not, get a look at the whole picture, but one of the main ones is to find things that are less costly than fish meal. Black soldier fly larvae does not check that box today. It might in the future, but it doesn't today. So what drove the decision process to use black soldier fly larvae and clam meal as fish meal replacers, as opposed to some more commercially relevant ingredients?
Well, the point with the black soldier was, the black soldier at the end has a good amino acid profile. It's kind of similar to the fish meal. Of course, the fish meal will always win, and at the moment it's not profitable or it's not sustainable, but it's because of the scalability of the production of the black soldier train. So that would not turn us apart or keep trying with that as an ingredient. So that would be the answer for the black soldier. Regarding the clam meal is not we don't use it as to replace the fish meal. But for instance, if you remember the palatability test, they didn't like it so much at 50%. But what if we add the clam meal byproducts? Would that help in their response to that by adding? So it's an additive, a supplement. It's an ingredient to add palatability, not as a replacement per se.
So another aspect of the clam meal is that it's probably never going to be available in large enough quantities to be used for a grow out diet. But if as an ingredient in larval diets, that sort of thing, it possibly could you can sustain a higher cost for that ingredient.
Yeah.
And then on black soldier fly meal, we are working with a group that is looking to scale production to get it to be competitive. So, basically we're at the real early stages. And I wish Nick was sitting here. He went to get a cup of coffee so he didn't fall asleep, I guess. But he's actually going to be making an effort on this project towards more work with black soldier fly meal that we'll do here on site. So we'll set up a colony so we can start testing, what materials you can use to feed black soldier flies to enhance them for marine fish. I'm pretty sure that's what he's talking about doing. Maybe Marty has had additional discussions with them.
I did talk to him about that.
Oh, yeah. Good deal.
So if I can build on what Fernando said, in terms of clam meal, was it's private industry, right? And what they wanted to do is get FDA and AFCO approval for fish. And they've received that based on the work that we've done. And the black soldier fly people are in that process and working with that. But to meet when they get to scalability, and they have a market to go to.
Nicole has a question.
I think Marty just kind of addressed it, was the black soldier fly has been being done for a really long time, and I know the FDA process of getting that approval has been going on for decades. And a lot of that is because they've changed staff and changed rules and changed requirements. And I think it's interesting, but until it's FDA approved and has good pricing, it's going to be rough. But I'm glad to know that going and getting FDA approval is on the list of things that will be happening now. Thank you.
Yeah, just a follow up to what Scott had asked about the clam meal diets, because we change and try different things based on price for broodstock diets, and change a few, almost half a year ago, more to a clam-based diet, more on the wild side, and seen a good, anyway, end result with broodstock and egg quality. But from a meal standpoint, you deflated my bubble, Paul, by saying it's the commercial availability. I was actually going to ask a non-presenter, but use like a price comparison, you know, where that either shrimp byproduct meal or clam byproduct meal is, you know, compared to fish meal, and see if it's ever going to be a, you know, potential substitute. I don't know the price question. Might be answered by the quantity question, or answer in terms of that, but yeah, we'd like to see it. Let's just say we've seen really good.
Some of it depends on the quality of the ingredient, you know, like with shrimp processing byproduct. You know, that there's a lot of that there, but it's a really low quality item, right? And with the clam though, that's a.
The clam is byproduct of processing of wild clams. So it's, you know, it's going to be limited just in the fact that the best parts go to the human consumer, right? So that you can have good clam chowder. But so, you know, it's basically the water that comes off of it. It contains a lot of proteins and that sort of amino acids that, and then you know, trimmings and whatnot. So, you know, it's always going to be limited by the size of the wild crop and the fact that it's a byproduct. So, but it is it's high quality byproduct. As I don't know much about the shrimp byproducts, probably mostly shell and that sort of thing.
It's heads and shells.
Which is going to be a lot of chitin, so which is indigestible. Whereas with the clam, it's not. You know, it's good protein. So, in my understanding.
Yeah, that's what we've seen in terms of ingredient samples from.
But it's always going to be limited. Now, if they start taking that clam, all the clam, which is never going to happen because we like to have it in our chowder, right? So.
It's interesting, the various, again, I am by no stretch an expert in that, but propeller clam, quahog clam. And just from a wholesale standpoint, the price is actually better than a lot of other wild feeds we were given our stock, actually, competitively speak. Now, it doesn't mean it turns into a cost-effective feed and your main feed ingredient or protein source, but I was surprised at the cost being lower than even what would anchovy or krill. You know, we would feed krill not primarily, but as a main, you know, brood diet. And then with scarcity and lack thereof, we started to look elsewhere, and the clams are actually much more cost effective. And I think nutritionally, we've seen just as good results, if not better. Krill. Anyway, I digress, but we like clams. So I will go to the processors of clams and fight my battles to see if we can work.
You know, when it comes to like a specialty diet, though, like a broodstock diet or larval juvenile diets, you're not talking about needing as much.
All right.
You know, if it's to elicit a gustatory response or to provide something that's missing in the diet, then, you know, it makes sense to have that more expensive ingredient for your broodstock, because that translates to many pennies, you know, in the high quality egg, or many more pennies in the high quality egg, for instance, you know, so.
So in terms of if we can just for a second stay on the clam meal. they had done some preliminary testing and FDA wanted to see a 1 times 2 times 3 response. So they looked at 1%, 2%, 3%. They were looking at it as a palatability enhancer. But they also wanted to know how much can be included. So we did 10, 20, and 30%. And Fernando, I think we found 20% was fine.
Yes.
Yeah, the other side of the equation, not to digress or monopolize this, was a lot of focus on the proteins, little on the fats of these game fish, you know, especially, you know, Pompano, I talk selfishly about, I know we talked offline, Scott and others, but you know, we use anywhere between a 12 and 18 of the smaller diets. But not a lot of information out there on that, what's appropriate, you know, in terms of the fat inclusion percentage or really the makeup thereof. So anyway, just future talks. Now we kind of talked about the past and what we've done, just something to point in the future. It'd be really interesting. There's a lot more questions and answers on the fat percentage side of those diets and what they're made of and who can make them. And I had a whole education a couple months ago on the subject of coatings and what can be inclusion or not. And so there's limiting factors from a operating milling standpoint, but there's also what's best for fish and go from there. And have you ever worked with that, Marty? Have you ever looked at the
Yes,
fat percentage, the other side of the
yes.
diet for them?
We found 18% was optimum. So, Alan and I have kind of a difference there.
Well, he's not here.
Yeah.
See if
So
it's-
so I can talk about him, right?
Trash him if you want.
He believes that, it's a little bit lower. And we have differences in opinion on optimum protein, lipid, energy. So his is a little lower than what we've determined.
Is Alan online now? Can he,
Do you see Alan's name? Alan has not joined us. We did have a question from Jenica. So Jenica had a question for Kevin that he answered. And the question was, oh, there's a couple of different questions here. Let me go up. Kevin, how old were the brood stock during the diet studies? And Kevin responded that those were 7-year-old brood stock. And Nicole has a question to Kevin. Was the diet to egg study done at Kevin's place? And what was the temperature on that nutrient diet to egg? Kevin, can you unmute and respond to that?
Sure. Yes. So the broodstock nutrition work was done at our laboratory in Mission Bay in San Diego, and the temperature was ambient, so ranged from 15 to about 23 degrees Celsius.
Thank you.
Yep.
And I think that's all we have for the online questions right now. You can either unmute and ask a question directly, or you can put something into the chat and I will relay it. There's the chat.
This is Marisol here from Purdue. I have a quick question about the issue of lack of inflation of the swim bladder as a problem in the early life stages. I think it was yellowtail. Kevin maybe mentioned that. I was just wondering what would be the potential causes of that, and could it be related to some kind of endocrine disruptions that could be found in the diet, or some kind of chemical or something else? I don't know. Just wondering.
Yeah, so swim bladder inflation has been an issue for us for a little while. I'd say a little while being a decade. And it's been on and off in terms of success. We've had batches of groups of fish with successful inflation around 80 to 100%, and then years where it's been 40 to 50%, which has been kind of one of the main reasons for this project, to really help us kind of hone in on what we're seeing. We're not 100% sure still, although some of the stuff I presented on in terms of culture temperature and photoperiod is helping us kind of mitigate some of those things. We've been able to do some trials looking at those on an experimental level, and then I'm able to do it on a production scale and seeing the same results on a production scale. So I just want to kind of repeat those with some different broodstock. The other question that we have is kind of the age of the broodstock that we have in captivity. We've had some older wild fish that have contributed to some poor spawns, and we're looking to look at bringing some new wild fish, and then also look at some younger F1s that we have on at our facility to kind of look at age of broodstock when they come through. But it definitely could be an endocrine thing going on. Although everything that we're looking at has been just trying to clean the surface, a bunch of different surface skimming techniques, looking at what's contributing to that, from the algae paste to the rotifers to anything that's producing oils that can go to the top. So again, all those factors that I presented on are ones that we looked at over the last 4 years. And the two that really pointed towards any type of improvement were photoperiod right now. And again, we're still looking at some culture temperature work. And we're also working with Auburn now to help us look at some stuff histologically to see if we can, maybe we're missing something earlier than the identification of the swim bladder.
If I can add.
Jenica said we're in the middle of brood nutrition study for F1s. There's been some interesting issues. Jenica, do you want to elaborate?
I can do that. So guys, if you don't know me, my name is Jenica Hawkins. I'm with Ocean Era out in Kona, Hawaii. So I worked with Cereola revoluliana with Blue Ocean Mariculture, and it's a preceding company for 10 years. We still do collaborative research with them. And we're, again, trying to develop some F1s because traditionally it's always been the wild capture brood that have performed the best, but for lots of reasons, we know we don't want to keep doing that. And we were looking to see what would be better to get them on like a frozen fish and squid type of diet early and compare that to a pellet-based diet. And we've really not been able to meet the nutritional needs of these fish as they're growing with like fish and squid, and even with supplements. We've seen some really stark differences, like beyond growth rate, just in health and resilience to stress. And so that's kind of why I was, looking to Kevin to see how old his fish were. I mean, obviously, if they're coming in as healthy adults, and then we kind of limit their diet to a fresh or frozen product, then they're doing okay. But yeah, again, trying to raise up these fish when they're like a year and a half old, we haven't been able to do it without. We're even looking to like start supplementing their diet with pellets again, because it's been such a stark contrast in their growth. So that's one thing we're in the thick of right now. So yeah, I appreciate the work that you guys are doing and being invited to the webinar today, because it's really pertinent to what we have going on.
Thank you. From Nicole to USDA and Harbor Branch. When will the genetic selective breeding work start in the hatchery and lab? Have we finished collating the genetics and identifying SNPs, and will those SNPs become public?
We are in the process of, so the projects that we described and Joe described were on growth. We received all of the sequences back just a week or so ago, 2 weeks ago. So we're in the process of the analysis of that data. We have a whole variety of SNPs that are likely relevant based on work that my PhD student did towards the beginning of this project, in the first couple of years of this project. So those give us a lot of targets to look at within the sequences that we have. And so that all has to be sorted out, of course, since we just got the sequences back. And it's many terabytes of data. It's terabytes of data that have to be analyzed. So it takes time, computing time to get that done. When will the SNPs be public? Yes, we'll publish them when we find markers. When we find markers, they'll be published. It's a relevant data. The project is publicly funded, and our objective is to develop the science and publish it, so it's broadly available. And then when we do have select stock, those select stock will be made available to the producers. Of course, what will, the process that we'll go through is they'll be tested in our labs first. We want to verify that any select strains that we produce are actually working, that they're getting better growth, that we have disease resistance, that we don't have any disease resistance issues. That's why we're building out the disease challenge facility that was mentioned, and it's getting very closer now to getting done. But when we do develop a line that has faster growth, it'll go through the disease challenge facility, because we don't want to put out a fast growing fish that's going to die from disease because it's non-resistant, inadvertently selected for non-resistance to diseases. So these things have to go hand in hand. So it's going to take a while. USDA has not yet hired their geneticist, but with Nick on board now, and it's his priority to fill out the science positions and tech positions on the USDA side of the collaboration. That's going to accelerate. So what we're doing now here, our part of the effort, is to build that foundation so that when the selective breeding geneticist does come on board, they've already got a firm foundation to hit the ground running. So that's why we're looking for markers. We're doing the groundwork that needs to be done. We have the full genome of pompano completed and annotated. It's been published in GenBase. So these are the things that we do to set that foundation. When we do have select strains that have been tested and we're confident, then they will be made available to seed stock producers, to farms like Joe's that do their own seed stock, and we'll make them widely available. USDA has mechanisms for getting germplasm to users. We'll use their mechanisms. So this is certainly, one of the main things we want to do on this project. So, and that in the last meetings, it was identified as a clear priority of the stakeholders to do this work. And, we've talked over the years that it's going to take it's going to take time. This is not a quick process. Now, once we do have markers, the process is much more accelerated over the traditional breeding methods. But, we're at the point of trying to identify markers. So.
What is your metric of disease resistance?
So it'll be disease challenge. We'll challenge them to disease.
What? I mean, not all diseases are equal.
Oh, yeah, exactly. So we'll have some targeted diseases that we use. Of course, one of the positions is a postdoc, so it'll be incumbent on them. So we're building out the infrastructure so that when that individual is on board with USDA, they won't have to build out the lab to do that component and working with the geneticist. So some of the target species that we've been looking at are some vibrios, amyloidium, and such. So, and those are clear diseases that have been pointed out by. We did some surveys early on of producers and other stakeholders, and those were identified as species of interest among others. Cryptocarrion, I've forgotten the name now. Cryptocarrion, yeah, is one of them. Yeah.
So, go ahead.
Different subject, so if it's on that subject, I don't want to interrupt.
So we had a postdoc here who started to write a book. Since moved on, he's in Spain, and he's been working with some folks in Spain. And they're going to turn it back over to Fernando and I to finish up. And it's on known identified disease issues, pompano, variola, and red drum. So we'll have a list that we can sort through.
Of course, you know, we can't look at every disease all at once, but
That
You know,
was
there'll
the
be those
genesis of the
targeted.
question, you know.
There will be those
Disease
targeted.
resistance is,
Yeah.
right, right.
It's a big well, just the selective breeding is a big question. You know, you start looking at how many different traits are possible. You know, we're starting at ground zero. Whereas you look at the list of traits that they use with trout and salmon and sort of thing, you know, it's as long as your arm, the traits that they've got heritabilities on. We've got heritabilities on none at this point, so we got a lot of work to do. So, but with Joe's help, you know, we're getting data that's going to help us really accelerate that program. And then once our geneticist is on board, it's, you know, that's.
We've been doing the slow old fashioned way of growth selective breeding and gotten down to F1s and we're seeing progress, but this is hopefully a fast track to what we've kind of taken on internally. My question though, to lead the jury going forward anyway, is that we've actually, for Florida pompano, we've had a lot of inquiries internationally as climate change and oceans warming, and this is more international and with cages, and pompano is just a great species. Is who else thrives in 31, 32, and we haven't tested much higher than that, but God knows what their limit is. But that's to my point of stress testing and doing trials. A lot of people are curious and substituting what they're already raising where sea level, you know, warmth is becoming an issue. Pompano is a great species to interject because again, of their tolerance. But in my defense and honesty, we've never really pushed that high point. You know, the RAS system, we had too many other walls before the, getting above 30, 31, 32 C was acceptable. But I think the fish could take it. So in future studies, if you will, or again, leading the jury, there are a few people I know, Rod and Dyer in Panama, they're seeing that in warmth. So not just the effect on growth and so forth, but then as they stress from that disease and then affect the brood stock, right? We're sitting here with a kind of controlled condition, brood system, but others aren't taking them from the cages and spawning and going right out. But is there a limitation? You know, so these are some of the things I talked to them about since we're a small ship on the commercial pompano market, but they have good concerns on the ocean warming and where the stress points are in pompano. And I don't know if you looked at that. Well, again, we haven't. We kind of looked at the bottom end of it for growth reasons and how cold can they take, but I don't know if we've ever looked at the heat tolerance in terms of the ceiling as that's concerned.
If Matt's still online, he can correct me if I'm misspeaking, but I think they've done that work at Moat. And I think it was somewhere around 38, 40.
Matt, can you respond?
Could you repeat the question again? I'm sorry.
No,
I'll
it was a long-winded one. So briefly, we've had inquiries for people to see where the ceiling was in terms of where you start to get collateral damage and the warm water effects on pompano, right? Again, we've only pushed maybe 31, 32 by accident in some of our systems, but in certain ocean climates, you're going to see even higher than that. But did you test a high range, Matt, or have you looked at it with pompano before other issues start to become secondary, like disease or stress?
I've been here for 20 years and I don't remember any studies where we've actually done any temperature tolerances with the fish. We tend to, like you, we try to keep everything at 30 or below, just in case of diseases, and just general stress of the fish. We don't see any boosts or any significant boost in metabolism or growth rates when we go above 30. So we normally don't even look at temperatures any higher than that.
Yeah. This question was more for the people who don't have a choice, right? Doing it in cages,
Yeah.
and you don't have a let's just say you're at the whim. And anyway, but that's good to know. Like I said, as to my thought,
I mean,
I know
it's
that
something we can do here. It's it's never been proposed.
I know that Moat has done it with red drum because it's a question one of my farmers have asked, and they found larval and juvenile upper threshold with red drum.
Which is what?
I'll have to go look through my notes.
Oh, okay.
I think Yeah, I have to look at my notes. I can reply back to everybody.
No, I just.
Or
curious.
Nicole Rohde can reply back, but yeah, they had a really good study on it. And it's, I want to say it's 27, but I'm not 100% sure where you start seeing impacts on growth and survival.
Now, you're just talking about optimizing? I'm trying to remember the study.
Yeah, it was optimizing because there was some discussion going back and forth on temperature thresholds. I'm gonna go look through my notes now if I can.
Yeah, that would be Marion's work, her PhD work. But I know that she never got anywhere near those higher temperatures that they're discussing right now. I can't imagine she took those fish any higher than 30 degrees C.
So this is the type of study that we can put, consider for the upcoming project plan. And we have a clear collaborator as well, John Stieglitz, because one of the things you would do with thermal tolerance testing, you would also want to look at respirometry and that sort of thing. So, to answer questions is, are they stressed, that sort of thing. So, so we'll make a note of that. And that's something we can clearly start to look at for Pompano. Of course, we'll do a deep dive in the literature to make sure nobody else has done it already, which is what we're required to do for doing our project planning. We have to show that what we're doing is novel, and that hasn't already been done, of course. But I don't recall anything but anecdotal information. Chuck Wyrick, who used to be on our previous project, would always say, we can't go above 30, 32. He would get real nervous but he was a nervous Nelly anyway. So, which is a good thing for a fish culturist. That's not a bad thing. And but I don't recall ever actually seeing a published study, so
That.
on thermal tolerance.
That Shrek publication that Kevin Lane and Nicole Rohde and.
Yeah, so
know if Matt
I don't know where
was
they
on
got the
that.
info, so.
Yeah.
I mean, it's not really rootstock anyway, survival. They can tolerate a lot, but how that interacts with productivity. I think
exactly, that's
is
where the question.
question.
Yeah. So where do you start to see reduced growth, that sort of thing, so.
Yeah, a lot of these questions are from people who are raising now sea bream, and they might like in the high 20s, but not so much in the low 30s. And so these are people looking to potentially switch over species in current operations. And again, there's not a lot of data out there on
Right.
Other than accidentally or intentionally, we've seen those numbers at higher temperature.
Well, there's particular types of curves that we need to develop for, and John showed some curves, some theoretical curves. You also want to do what we call a Van den Hoff's curve, that shows respiration over at different temperatures, et cetera. And that, tells you where your lethal temperatures are, where your maximum respiration is, and usually, and the response over temperatures. So, so it's very interesting, a physiologist is one of the job descriptions. So, and I've done quite a bit of work with thermal tolerance. Most of the work I did was on cold water thermal tolerance in the Midwest, but. Yeah.
Yeah, it's
So that's
an interesting question. Thank you for that one. Those curves, like you mentioned, Paul, are definitely a good way to approach that in terms of seeing thermal tolerance and seeing, because it's a sublethal endpoint in many cases, that's something where you're going to see it in that type of study, and that can help inform the culture practices.
I assume that was John Stieglitz.
Yeah.
Sounded like that.
Yeah, I don't know if
Yeah.
you guys have video there or not, so.
So, I mean, that's a good segue into, the rest of the discussion, because what we do want to discuss is get some input from our stakeholders about our upcoming project planning. It'll actually be a 3 or 4 year project plan, depending on how the administration and USDA So, something that you guys can look at going in, you know, when you get home, you can Google, NP 106 USDA ARS, and you should be able to find a site that takes you to a lot of information about the NP 106 is the national program for aquaculture specifically. So you'll see there's a lot of different species covered in the NP 106 action plan. So you can find a copy of the national or the Aquaculture National Program 106 Action Plan 2025 to 2029, which is the guiding document for our project and many other projects. You know, there's some high level information like the vision. The vision of the national plan is science-based uses of natural resources, meaning seafood demands for a growing global population. And the mission is to conduct research and deliver information and technologies that improve domestic aquaculture production efficiency, product quality, while minimizing impacts on natural resources. So that's basically our overarching charge on the project. And in developing our project plan, we will receive a specific document directing us in the sorts of research that we're supposed to do on the project. It's called a PDRAM. What does PDRAM mean?
Program Direction Resource Allocation Memo.
There
you go. There you go.
Karen hasn't, I think Karen just put the
Thank you.
plan in the chat for
Oh,
folks that are
great.
online.
Appreciate it, Karen. I knew there was
Of
somebody
course.
at USDA that would know what PDRAM was.
Yeah, I wouldn't expect anybody else to remember that.
So we will be directed, but we want to have the input from the stakeholder group to help us in guide us in meeting or putting together our plan within the context of the directives that we get. So,
And Nicole has asked about scheduling time to do exactly that. Do you have any ideas about scheduling more time to talk about the future plan?
I want to leave that to our research
Just
leader.
reach out and then it might be easier to do it in December, early December or after the holidays. But just reach out, we'll talk about it. I'm meant to get a letter from Karen on some of these issues to kind of start developing our plan. I think the way we're gonna look at it is a roundtable discussion like this, where maybe we can invite do this again for a longer period of time, but it's not gonna be, I want it to be open, let's put it that way, open and transparent. So of course, like Joe and everyone else can come and we'll see if we can set something up.
Thanks, Nick. That would be awesome. And I mean, I think we all benefit from this type of discussion where we have lots of different minds in the room, all these different perspectives, farmers, you know, leveraging each other's, you know, brain trusts here to get this plan going. Is there a timeline when you have to have it done?
That one I'm gonna talk with Karen about first, and then I can get back to you on that.
I can clarify a little bit. And
Thank you.
Nick's right. We are waiting on a timeline because we've asked for a delay in this project. And the reason was we were waiting for Nick to join us. We're waiting also for other scientists to join the project. And so, you know, we have a 5-year cycle. We're just now getting the reviews from the projects that started the 5-year cycle at this time last year. So they will be initiated, you know, December, January of the coming winter. So this will be a year or more behind, and we're waiting to see what that delay is going to be. So as was mentioned, it's going to be a 3 or a 4-year project. It's not going to be a full 5-year. But yes, Nicole, I do have your letter that you submitted for the listening sessions. Not this summer, but the summer before. So it's been more than a year. But I think another conversation to help form these would be very helpful. So thank you.
Thank you. Anything else from the folks on Zoom? Anything else from the folks in the room?
Yeah, I have this is Mark Drawbridge out here in San Diego. with Kevin Stewart. So I have a question. First of all, to lead off and say, we really appreciate having the opportunity to be a part of this group and talk about marine finfish that we all love. In terms of the scope of this project and the national plan and so forth, obviously there's a large regionality to the program in terms of species and so forth. So is that, as you talk about stakeholders, and is it, where are things going relative to the regionality? Is it going to stay regional? Or can you comment on that? I mean, in terms of what kind of input that you'd be looking for? Obviously, we have related species, but not the same species out here.
So Mark, this is Marty. That's one of the reasons that you're on board with us and why we invited Jenica out in Hawaii. You guys have similar interests, but I think we're trying to broaden it and not make it so regional.
So the intent is for the project to be national in scope with, of course, we're headquartered here in Florida, but, red drum producers are represented heavily in Texas, the cereal producers and are, out here in Florida, you in California and out in Hawaii as well. So, one of our intent is to keep the scope of the project broad nationally.
And that's one of the benefits of having Nick and the ARS folks on board with a nationwide mandate.
Thank you. Sounds good. We obviously, as you've heard, share a lot of the common problems and challenges. So it's good to have this kind of dialogue.
Yeah, we really appreciate your participation with us in the past few years. It's been very beneficial for all of us. So I hope for you too.
Absolutely. Thank you.
So we're also going to have the special session during the WAS conference. So maybe afterwards, maybe we can go for lunch or dinner to kind of just informally discuss. So I can get to know you guys and know some of the issues that you have. That's just one also idea. So we can kind of take those things into consideration for the next strategic plan.
Sounds great. We'll be there.
Yeah.
So Mark said he'd be there.
Okay, good. And what Scott was saying is that would be a good opportunity for a discussion, and we can even make it more formal every year going forward to discuss, outside of just a formal presentation, to just have a roundtable discussion at a WAS conference, if that makes sense going forward as well.
Sounds good. Thank you.
Concluding remarks, Paul?
Okay. Well, I appreciate everybody coming and presenting. This has been a really nice retrospective of the past few years of the project. I think everybody can see that a lot has been accomplished. We have a very good group that's working very collaboratively together, including institutes, ourselves, and the farms as well. We really appreciate the participation of the farms. We find the data that we receive and that the farm collaborators are helping us get to be invaluable in our understanding. When you go from laboratory to farm, there's oftentimes big differences in how the fish respond. So this ability to work on farms with you guys is just really invaluable in our understanding of what's going on. Also having the farm level insight into challenges and that sort of thing to help us to frame the questions properly that we're going to be asking is also, once again, invaluable. I sound like a broken record, but it's just expression of our appreciation for the assistance that you're giving us, and Also our other collaborators, we really appreciate what you've been doing, helping us to really accelerate our accomplishments on this project, and you've all made it really a very successful project in the first few years. And now we anticipate with the USDA, Nick on board, and the new USDA scientists being hired ASAP, that the project will just accelerate in its achievements. So we will be having continued discussion on the project plan, going forward. We really appreciate all the input that we get while we're developing that plan, so that we can form the questions within the scope that we're directed to. And I know that the discussions based on our past discussions with our stakeholders, et cetera, is always going to be fruitful, always going to generate good questions and good feedback. And we really appreciate that. Thank you all for coming today.
Can I say something?
Go ahead, Marty.
I have to have the last word.
You always do. You're like my wife.
Yeah. Not as pretty.
No.
I'd like to echo what Paul said. Thank you all for participating today. But I really want to give a special thanks to Jim, Allison, and Fernando for bringing this all together.
Carly.
And Carly.
Got guys.
Yep.
All right, thank you, everybody.
Bye-bye, thank you.
Bye, thank you.
See you again soon.